right, this is Saxon Algebra 2, lesson 39. So we factored quadratics. Now we're going to factor two terms, but both of these terms are going to be perfect squares and they're going to be subtracted. All right, so if I have x squared minus 1, both of these are perfect squares and they're subtracted. 100% of the time when I have perfect squares and they are subtracted, my factors are going to be conjugates. So let me tell you what a conjugate is. So conjugate is like x minus 3, x plus 3. The first and the last terms are the exact same. The only difference is the sign in the middle. These are called conjugate terms. So it could be x, y, z minus a, b, c times x, y, z plus a, b, c. It could be x plus I times x minus I. I use that I because we're going to start working with I in just a little bit. It's imaginary, it's a complex number. All right, so to determine the factors, you ask yourself, what's the square root of x? What's the square root of x? X. What's the square root of 1? So these two numbers are going to be in my factors. It's just going to be plus and minus. It's going to be x plus 1 times x minus 1. So you just look at the original terms. You ask yourself, what is the square root of that value? It's going to be plus and minus those values. They're conjugates. So we use conjugates a whole lot. All right, so if I have 9x squared minus 81, what's the square root of 9x squared? 3x. What's the square root of 81? 9. It's going to be plus and minus those terms. 3x plus 9 times 3x minus 9. Okay, we're not merely factoring. We're solving these. So they're going to be set equal to 0. We'll work these two. And then I'm going to work a harder one. All right, so same thing. If this factor is 0, it doesn't matter what the other one is. So you set all of your factors equal to 0 and solve for x. And we're going to see something that is true with conjugate terms. So I subtract 1, I get negative 1. I add 1, I get positive 1. You will always get conjugate solutions, plus and minus the same solution. Same thing with 3x plus 9 and 3x minus 9. I subtract the 9. I have 3x is negative 9. I divide by 3. I have x is negative 3. I add the 9. I have 3x equals 9. I divide by 3. X is positive 3. So your solutions are always going to be conjugates, plus and minus, the same number. All right, what if I had okay, a little harder. Harder than probably anything in your textbook. I have to ask myself, can I take the square root of each of the terms, and then I have to make sure that there's a subtraction sign here. All right, so look at the first term. Just take each one individually. What's the square root of 16? 4. What's the square root of x to the 6th? You take half of the exponent.
3.
X cubed. Take half of the exponent. Y to the 4th.
Y squared.
Yes, minus. What's this one? Square root of 64. Square root of a squared.
8.
Oh, I didn't mean to put a minus sign. Although it's going to be plus and minus, right? All right, these are my square roots. It's going to be 4x cubed y squared minus 8a times 4x cubed y squared plus 8a. We can't solve for that because we have 3 variables. You only solve when you have 1 variable.
So that's the answer.
Well, that's it factored. Okay, now let's work the examples in your textbook. I just want you to see how you can take the square root of different values and factor them. All right, now on page 178. Here we have 4x squared minus 9 equals 0. All right, how am I going to factor this first term?
Square. So 2x
2x.
minus 3.
So what are my factors going to be?
2x plus 3 and 2x minus 3.
That's correct. 2x plus 3, 2x minus 3, set it equals 0. You set each factor equal to 0, and you solve for x. And I'm expecting my values of x, my solutions for x, to be conjugates, plus or minus the same value. So, subtract 3 from both sides. I have 2x equals negative 3. I divide both sides by 2. X is negative 3 halves. For the second factor, when I add 3, I'm left with 2x equals 3. Divide by 2 both sides. X equals 3 halves. They are plus minus the exact same number. And that is what I was expecting. All right, the next example. 81m squared minus 25. 81m squared minus 25 equals 0. Jacob, can you help me with this one? What's the square root of that first term?
9 and m.
9m, second term.
Minus 5.
5, yeah.
5. Okay, so what are my factors going to be?
9m plus 5 and 9m minus 5.
Correct. Then I set each factor equal to 0 and solve for m. Okay, I feel like you guys are trekking with me, huh? All right, so we're going to subtract 5 from both sides. I'm left with 9m is negative 5. Divide both sides by 9. M is negative 5 ninths. Doing the same thing with the second term. Adding 5 to both sides. We have 9m equals 5. Dividing both sides by 9. M is 5 ninths. I was expecting conjugate solutions, and they are, in fact, conjugate solutions. All right, the second part of this lesson goes back to geometry and has to do with parallelograms. All right, there are some things that are true about every parallelogram, if in fact it is a parallelogram. All right, so I'm going to draw one, and then we'll go over what is true with parallelograms. And then we'll work the one practice problem. All right, so a parallelogram is almost like a rectangle that has been squished to one side. Push the top, maybe push. But here's what is true about every parallelogram. The opposite sides are parallel. So these sides are parallel, And these two sides are parallel. They're called opposite sides. Opposite sides are parallel. Y'all kind of remember this from geometry? So opposite sides are parallel. This is the symbol for parallel. They're also equal in length. So that length equals that length. This length equals this length. So they're parallel and equal in length. All right, so that is true about every parallelogram. Opposite angles are also equal. So that angle equals that angle. Opposite angles are equal. Always. Adjacent angles, here's adjacent angles. Adjacent angles, they are supplementary. What supplementary mean?
Both add up to 180.
The sum of them is 180, yes. So the adjacent angles are supplementary. And there is something true about a diagonal. Remember, a diagonal goes to non-consecutive vertices. So here's a diagonal, and here's a diagonal. And the diagonals, they bisect each other. They're not both equal in length, but they bisect each other, such that the length of this portion of the diagonal equals the length of that portion. And the length of this portion equals the length of that portion. All right, so I will draw the parallelogram. That's practice problem C on page 179. This is actually a rhombus. Okay, so we need to talk about rhombuses because there's something also different about a rhombus. So a rhombus is a parallelogram, but it's a parallelogram that has all four sides equal. There's also something unique. So it has all of these things are true. Opposite sides are parallel and equal. The diagonals bisect each other. Opposite angles are equal. Adjacent angles are supplementary. But there's also something true about the diagonals. Where the diagonals intersect, they form right angles. In fact, there are 4 congruent triangles. All 4 of those triangles are congruent. I've seen that on the ACT. Should be a 2-second answer. You know, they'll ask, what is the measure of that angle? 90 degrees. All right, so that's the picture in practice problem C. It is of a rhombus. And there is something else unique about a rhombus. Okay, I'll tell you that in a minute. I don't know why I'm waiting a minute, but okay, here's the rhombus in the book. Oh, I do need to tell you one more thing.
They have a reflex angle in them.
This is a reflex angle. I don't know if your geometry told you what a reflex angle is, but a reflex angle is greater than 180 degrees. A reflex angle is greater than 180 degrees. Here's your reflex angle. So you can have angles as big as 500 degrees. You can have 1,000 degree angles. You can have we will deal with that when in pre-calculus, those angles. All right. Also, with a rhombus, because our sides are equal, this diagonal, it bisects that angle. That angle is bisected. All right, so x is going to equal b. The value of x is going to equal the value of b. Okay, so quickly, what's the measure of c? Z. 90 degrees. Z is 90 degrees. That's right. So we know x equals b, right? But what's the sum of x and b? We know all the way around is 360.
So it's gotta be 54.
So it's 54. Is this whole angle is 54 degrees. Half of it goes to x, half of it goes to b. So what's half of 54?
Why would it be 54?
27.
Okay, look, because 54 plus 306 is 360, right? All the way around. All right, so half of 54 is 27. So x is 27 degrees, b is 27 degrees, because that angle is bisected by that diagonal. Okay, if this angle is 54, then what is this angle? They're adjacent, so they are supplementary.
Okay, so it's gonna be.
So it's going to be 180 minus 54, which is, what's 180 minus 54?
126.
126.
Half of that.
A is going to be half of that. So A is, this feels just like an ACT problem.
73.
Half of 12,
Oh, yeah, that's right.
half of
So
6,
63.
63 degrees. Okay, so there's one more thing I want you to know. I'm checking my time. If I have time. Okay, I have time. There's one more thing I want you to know about rhombuses. It's not in your textbook. It's not in any of your textbooks. So if I say the measure of this part of the diagonal is 4, well, you should know the measure of that is 4. And if I say this is 6, then you should know that is 6. There are 2 ways to calculate the area of a rhombus. I'm going to show you the hard way, then I'm going to show you the easy way. All right? These are 4 congruent right triangles. All right, so here's the 2 legs. The area of a right triangle is 1/2 leg times leg. 1/2 leg times leg, because one is the length, one is the altitude. Okay, so what's half of 4 times 6? 12. So the area of all of these is 12. So I just take 4 times 12, and that is 48. Whatever the measurement is. Inches squared. Or you can take 1/2 times diagonal 1 times diagonal 2. You just multiply the diagonals. So half, diagonal 1 is 12, right? 6 plus 6. I added wrong in my class the other day. I use these same numbers. 4 plus 4 is 8. All right, so what's half of 12? What's 6 times 8?
48.
This piece is not in your textbook.